Welcome to an in-depth look at stored cross-site scripting, commonly known as stored XSS, a critical web security vulnerability. Stored XSS is a type of attack where malicious scripts are permanently injected into a web application and saved on the target server. Unlike reflected XSS, these scripts are stored in places like databases, message forums, or comment fields, waiting to be executed. The malicious script then executes whenever any user visits the compromised page, without needing to click a specific link. Let's explore how a stored XSS attack typically unfolds. First, an attacker identifies an entry point in a web application, such as a comment section or a user profile field, where user input is stored. The attacker then injects malicious code, often JavaScript, into this input field. If the application is vulnerable, it stores this malicious code directly in its database. When other users visit the page displaying this stored input, their browsers execute the malicious script. This script runs with the same privileges as the legitimate site, granting the attacker access to sensitive data or the ability to perform actions on behalf of the user. The impact of stored XSS can be severe, leading to various security breaches. Attackers can steal session cookies, passwords, or personal details, resulting in full account takeovers. This can also lead to data theft, session hijacking, and even the distribution of malware to unsuspecting users. Furthermore, stored XSS can cause website defacement, redirection to malicious sites, and significant reputational and financial damage. Consider a social media platform where an attacker posts a comment like script alert XSS attack /script. When other users view this comment, the script executes in their browsers, potentially stealing cookies or performing other malicious actions. Similarly, injecting malicious JavaScript into a user profile field or a blog comment can compromise anyone who views that content. Preventing stored XSS requires a multi-layered approach. Always validate and sanitize user input, using strict allow lists to filter out malicious characters and scripts. Encode user input before displaying it to prevent browsers from interpreting data as executable code. Implement content security policy headers to specify safe script sources and use secure frameworks like React or Angular. Regular security testing, including DSD and penetration tests, is crucial for identifying and remediating vulnerabilities. Finally, protect sensitive cookies with the HTTP-only flag, apply the principle of least privilege, and deploy a web application firewall. By understanding stored XSS and implementing these preventative measures, web developers and security professionals can significantly protect their users and systems.